Hi everyone. Thanks for tuning in. This is Nate, a MerSynth, talking to you from Gradient N. In this video we set up and train a fully connected image classification neural net using the Superman or Batman dataset downloaded from Kaggle. The link is in the description box below. First, we'll select the images from the dataset and add them to the net. We've renamed the images as Superman, Batman, or Superman and Batman for images that show both. We can see that there are a variety of image types in the dataset and that they are of different sizes and shapes. We'll go ahead and fast forward through the image initialization process. We can see that there are 975 images with varying sizes and aspect ratios. We've set NNetDesigner to uniformly convert the images to 100 by 142 pixels. We'll first pull out and drop an image input layer. Next, we'll select Net from the Tools window and click on the drawing area. In the Net dialog box, we'll turn off Input and Preprocess nodes, we'll set the number of layers to 3 and the hidden layer width to 10, and we'll set the number of output nodes to 2 for Batman and Superman. We'll leave the activation functions as sigmoid and then we'll click OK. We can then place the net where we like and click on the drawing area to finish. We can use the auto router to finish up our connections. We align the arrow in the direction we want to forward propagate and click on the drawing area. Then we'll select the Edit Process option and set the processes for our output nodes. When we highlight our output nodes, we make sure the Image Name Parser tab is selected and then we select Batman from the Image IDs list for our first output node. And then we select Superman for our second output node. The last thing we'll do before saving is to select the Train tab and click on the Validation option. We'll select the Sample from Training Set option and set the percentage to 5. Then we'll save our net, naming it Superheroes. When we reduce the NetDesigner window, we see that we have a second instance of NetDesigner ready to set up. After we fit our first net to its window, we'll go ahead and open the same net in our second window. We then select the hidden nodes of our second net and set their activation functions to ReLU. Remember that the hidden nodes of our first net used sigmoid activation functions. Finally, we'll save our second net with the name Superheroes 2. We start training for our first net and fast forward through its initialization. Then we'll start training for our second net. And again fast forward through initialization. After watching training for a bit, we'll jump forward in time until training is relatively complete. After training for a while, we can see that the net on the left with sigmoid hidden nodes took a while for training to start to make progress, and that its training had to climb out of a couple of local minima before settling. The net on the right with ReLU hidden nodes learned pretty smoothly and trained in about a quarter of the time as the sigmoid net. Next, we'll open the output data windows for each net and save their data. We can view the net output files in Excel. At the top of the output files are train and validation classification matrices. For the sigmoid net, we can see that we have a train accuracy of 99.8%, with one Batman and one Superman misidentified. We have a validation accuracy of 71.2%, with 12 Batman and 3 Supermen misidentified. For the ReLU net, we can see that we have a train accuracy of 99.9%, with one Batman misidentified. We have a validation accuracy of 72.4%, with 9 Batmen and 7 Supermen misidentified. It's important to remember that when we use the sample from training set option for our validation set, the validation set is randomly selected for each training run. If we repeatedly test the sigmoid net against the ReLU net, we will get slightly different results each time, with sometimes sigmoid winning and sometimes ReLU winning, as different validation images are selected for each set per training run. Thanks for watching. We'll see you next time.